We're looking at quadratic equations. Of course, when we're talking about quadratic equations, we're talking about a second degree polynomial. So far, again, everything that we have looked at has been the first degree polynomial, which means that whatever your leading coefficient is has a degree of 1 or an exponent of 1. So the linear equations we saw previously were all first degree polynomials. Now we're getting into degree 2, or what we call as quadratic, and you will see your leading coefficient has a square on that x variable. So that's your x squared, and I can move this up a little bit. So you can see that's ax squared plus bx plus c equals 0. This is again what we would call as the standard form for the quadratic equation. Again, your x variable, well, is the variable, the unknown value. And then of course you'll see a, b, and c are real numbers. And because this is a degree 2 polynomial, we don't want that coefficient on the x value, that a, to equal 0, because again, 0 times x squared would end up becoming 0. And my second degree polynomial term would disappear, and I wouldn't have a degree 2 equation anymore. So that's why we're restricting a cannot be equal to 0. So in this section, we're actually going to look at how to solve a quadratic equation, and we're going to look at different methods over here. We're of course starting out with one of the basic processes, which is solving quadratic equations by factoring. And you remember I mentioned last time that if factoring is something you haven't done in a while, it may not be a bad idea to go back and practice a little bit. Because as you can see, we're going to make use of it here on how to solve a quadratic equation. So basically, it would depend on what type of polynomial you have, if it can be easily factored. If it cannot be easily factored, then we'll look at a second method. Okay, so if it's not factoring the way it's given to us, what can we do to change that? So when we are talking about using factoring to solve a quadratic equation, we talk about the zero factor property. And basically we are saying, once we get our quadratic equation factored, you know, when we break it up into its two factors, obviously my quadratic equation is set equal to 0, as we saw in the definition here, ax squared plus bx plus c equal to 0. So continue with that same thought. The idea is once I have factored my polynomial, degree 2 polynomial equation into two factors, that would be a multiplied by b, it is still being set equal to 0. So then to solve and get our solution, we take each factor and set it equal to 0 separately. So then we say, okay, now we have a times b equal to 0. Using the zero factor property, we can say either a has to be equal to 0 or b has to be equal to 0. And using that idea, we come up with our solutions. Because keep in mind, if you are multiplying two numbers, a times b, and your product is coming out to be 0, that means either a has to be 0 or b has to be 0. I mean, think about it. If you had two numbers being multiplied together and they're equal to 0, this number could be, I don't know, let's just call it 3. But if my answer is going to be 0, that means the second value had to be 0. In that same sense, obviously the first number could be 0, and then the second one could not be, you know, could be a non-zero number, and still you're going to end up with a product of 0. So that's what the zero factor property says, and that's what we are going to use. I think I actually have an example of this going on. All right, there we go. So solve the equation by factoring. Let's make this one. We talked a little bit about factoring last time when we did the completing the square for, you know, completing the equation of a circle so that we could find the center and radius. In completing the square, however, your leading coefficient on the x squared term was 1. Remember, we said make sure that that one is 1, and then we use the whole b divided by 2. quantity squared. So this one you can see starts out a little bit differently because my leading coefficient is not 1. And in fact, in this case, it's 6. So you have 6x squared minus 13x plus 5. Anybody have any ideas on how you factor an expression like this? Where you would begin? So of course, keep in mind when we're talking about factoring, you're actually talking about product, right? Because you multiply the two factors to get your answer. So your addition wouldn't work. Because, remember when we are talking about combining like terms, we couldn't really add x with x squared, right? X squared only gets added with x squared, x only gets added with x. So you're actually using, I guess, division in a way to separate the terms. So there's two ways of doing this. One is, of course, the trial and error method, which I understand is more commonly used when factoring is being taught. So there's different ways of doing that. And let's do this on the side, this graduate here. So let's start with that 6x squared term, our leading one. Now 6 can be broken down into 6 times 1. 6 can be broken down into 3 times 2. Is there any other combination which would give us 6 outside of these two? Yes, no? It would be the same thing, right? Still the same two numbers. So there's no other combination. So that's one place you start out at, which means I can either break down these guys as 6x and each of the terms gets an x. So you can break this down into 6x and the other one into x. Or you can break it down into 3x and 2x. So that's how you split up that leading coefficient term. And depending on how many multiples you can come up with for that leading coefficient, that's how many sets of trial and error sets you would have to do. What are the factors for 5? Very good. Only 1 and 5, which means this is where, again, trial and error will happen. So I've got 6x and x, I've got 1 and 2x. So the way this works is I can do 1 here, 5 here, or I can do 5 here, 1 here. Same thing on the other side. I can have 1 here, 5 here, 5 here, 1 here, right? So we're kind of giving each option of, does it go with this guy or that guy? My middle coefficient has a negative sign, right? I have a negative 13x in there. So what that tells me is, what sign should I put in my parentheses? In both of them or one of them? Both. Because negative times negative gives us positive, and we have to get positive 5 at that constant term. So all of these guys should have a negative. So obviously we are choosing between, out of these 4, which one will obviously take us back to the original expression that we had, to the original polynomial. And this is where we bring in our little calculation here. So we know we're going to get 6x squared when we multiply these two guys. We know we're going to get 6x squared from here, 6x squared from here. So we don't really have to check for that. We know we're going to get positive 5. We are going to get positive 5 when we multiply negative 1 with negative 5 and negative 5 with 1. Same thing's going to happen over here. And I'm going to get my positive 5. So I don't really have to check for that either. The only number we are checking for is going to be the middle term, negative 13x. And the way you do that, of course, is we multiply. Remember, this is still, we're doing FOIL. So this is the O and the I part of the FOIL, the outer and the inner terms. So this one will give me negative 1x. When I multiply these guys together, what will that give? 6x times negative 5. Negative, right? And when you add negative 30 with negative 1, you get negative 31x, which is not what our middle term is. So that tells me this guy does not work. It's not giving me the correct middle term. And that's your process. We'll do the same thing here. Negative 5 times x is negative 5x. Positive 6 times negative 1 is what? Negative 6x. What does that add up to? Negative 5, negative 6. Negative 11x, which again is not my middle term. So obviously 6x and x was not the breakup we needed for that first term, 6x squared. So it's got to come from one of these two terms on the right. So let's check this one. Negative 1 times 2x is negative 2x. What is 3x times negative 5? Negative 15, and when you add that together, sorry? You've got 15 and negative 2. Negative 17x, which again, does not give us the number we're looking for. So the last guy is our hope. Let's see what do we get from here. Do you get negative 13x from this one? Yeah. What is negative 5 times 2x? Negative 10x. And 3 times negative 1 will of course give us negative 3x. Negative 10, negative 3 is alrighty. So you can see this is going to be our answer. 3x minus 5, 2x minus 1 is what your factor is going to be. So like I said, this is a trial and error method, and I have literally walked you through what it looks like when you're doing the trial and error method. This is not my preferred method, but I am okay if it is yours. Because at the end of the day, you have to be comfortable with what you're doing. And the reason I don't like the trial and error method is because if I go about doing this algebraically, I know I'm going to get the complete answer and I don't have to keep trying the different combinations. But a lot of times that can seem, I guess, a lot of work sometimes for people. And like I said, pick which one you think works the best for you. So I'm going to show you the other method. You don't like it, ignore. So this is how you start with the second. Obviously, we have our polynomial 6x squared minus 13x plus 5 equals 0. So the way this guy works is you take your leading coefficient. You take your leading coefficient from the first term and multiply it with the constant term. So that's going to be the 6 from the first term, 5 from the second term. 6 times 5, of course, gives us 30. And then we look for factors of 30. So what can 30 be broken down into? Sorry, I need to mention that factors of 30, but they have to add up to the middle term of negative 30. So we multiply 6 and 5, the leading coefficient with the constant term. We get our product, which is 30, and then you're trying to find factors of 30, which will add up to negative 13. 2 and 15. Now remember, in this case, since we just saw in the previous example, both our numbers have to be negative. So if you actually look at negative 2 and negative 15, it's not going to add up to negative 13, is it? It's negative 17, isn't it? So this combination actually does not work. So what are the factors of 30 will add up to negative 13 if both numbers are negative? Very good. It will be negative 3 and negative 10 because they will add up to negative 13 and this combination. Carmen, are you okay so far? Did you have any questions? Can you hear me? Do you have any questions? Alrighty, guys, so that's going to be your breakup. So the way we go about doing this, let's go back to green. We've got 6x squared, but now using the negative 3 and negative 10, we're going to split this up. And it honestly doesn't matter which number you put forward. We can do negative 3x, negative 10x, and then bring the plus 5 down as it is. So what we have done is we've taken these factors after we multiplied 6 and 5 and used that to split our middle, right? Into -3, -10, or you could have done -10 first and then -2. All right, now this is what we call as factoring by grouping. So we're going to group the first two terms, and we're going to group the second two terms. And you find what is your greatest common factor between each of the groups. So between 6x squared and 3x, what's common between the two terms? 3 and, sorry? No, 2 wouldn't go into 3, right? Yes, so take the letter with the number. So between 3 and 6, 3 is common, and between the two x squares and x is common. So we take the 3x outside. 3 goes into 6 2 times. You've got one of the x's outside, right? But we had x squared to begin with, so 1x comes out, but 1x will stay behind. Minus, you've got the whole 3x outside, so we don't really have anything left over. So remember, this is what we call as a placeholder. You're putting 1 as a placeholder because the idea is if I go back and multiply 3x with the parentheses, I should come back to that first grouping. So 3x times 2x, 6x squared, 3x times -1, -3x, right? It takes me back. We're not changing anything. We're just rewriting it, breaking it down. Now, here's the thing. You will see in my next grouping, my 10 is starting with a negative number, so you do need to bring that negative outside. Okay? Now, between 10x and 5, what is common? 5? What about x? Is x common or no? No, because the 5 doesn't have an x, right? So only the number 5 is going to be common. Bring that guy outside. Now, since we took this negative sign in front of the 10 outside, it's not going to make it inside the parentheses. So 5 goes into 10 2 times, and you still have that x left behind. Now, same reason here, guys. Since we took this negative sign outside in front of that 5 in our factoring, the sign for that +5 in the grouping is going to change. So that was plus. We took a negative outside, so this guy will actually become negative. And here's the thing. If that sign in front of the 10x had been plus, this sign would not have changed. But because this sign was negative in front of the 10x and we had to bring that negative outside, the sign in your parentheses changes.
The 5, I thought it was supposed to be a -1.
Sorry, yes, that should be a -1. Same thing. Yes, thank you. I am apparently not paying attention. And that's a good catch because if we did do this correctly, which obviously I hadn't, these two parentheses should end up matching. So you should have 2x minus 1 here, and you should have the same value, 2x minus 1 here. That's how you know you have factored this correctly. If you don't, like if I hadn't caught that, like you guys hadn't caught that 5, then I would have known, oh, I did something wrong because my parentheses are not the same. Then I would have gone back and fixed it. So yeah, that's a really good way to know, okay, I did it right, I'm on track. Don't make it happen like, I'm trying to make you guys look the same. No, it should happen on its own if you do this correctly. All right, so you're almost there. Now we are going to take these guys, since they are the same, we're going to combine them together into one single term. So 2x minus 1 is one of our factors, and 3x minus 5 is our other factor. We said that equals to 0. And again, you can check and see we're going to get the same answer, because when I multiply these guys together, I get -3x. When I multiply these guys together, I get -10x, which of course adds up to -13x. And of course, we know we did this right. So this is the algebraic method. Like I said, this does seem a little bit different, but I know it works every single time. So this is how I would go about if I'm not able to see directly, like how can I factor these? But you can do the trial and error method. So pick which one works the best for you. Alrighty, I'm going to save this. Right, right, so now we have factored this. Now the second part is using the zero factor property. And remember, the zero factor property is we've reached this stage. We've got A times B equals 0. Now we need to set each one of the factors equal to 0 so that we can find our solution. All right, so let's start with the first one. We have 2x minus 1 equal to 0, or 3x minus 5. Now you can write this in one line because obviously you can see I don't have enough space. I'm writing it as two separate. Alrighty, get your x by itself. So basically add 1. Move it to the other side. You've got 2x equals 1, and then of course divide by 2. And you get x by itself. We have x equals 1 half. Can you tell me what we get from the second one when you do 3x minus 5 equals 0? 5 over 3, very nice. Same thing at 5. And 3 is not on the 5. X equals 5. As of looking, but those are the two answers we are looking at. X equals 1 half and x equals 5 over 3. If you wanted to check and see if this solution works, you can take that 1 half, plug it in for both the x values inside the equation. Same thing with 5/3. Plug it back in and you should have 0 equals 0 as your true statement, and that's how you would know you have the correct answer. Okay, let's check this in. So you will be entering both. Again, no spaces, guys. Just put a comma between the two solutions. So we have 1. So how you factor the polynomial is up to you, but this second part where we take each factor and set it equal to 0, find our solution will stay the same. Questions on this example? Let's see if we can get you this to do this. So number 2. So first thing you should notice is it's not equal to 0. And obviously it's not given to us in the ax squared plus bx plus c format. So start by doing a FOIL on the left-hand side and let me see what do you get when you multiply y minus 3 with y plus 1. There's one, before you can start factoring it, you do have to get 0 on the right-hand side. So you cannot factor it without getting that 0. So the first step would be obviously multiplying y minus 3 with y plus 4, as I said, and then moving that 30 over to the left-hand side, combining it with that constant term and trying to get 0 on the right before you can even begin. So what is your FOIL result when you multiply those two parentheses together? And this one will actually work with this one. We will have a computer on screen. So yeah, normally, if you are going to end up with positive in the middle term, that means a larger number usually. Positive, because you know, you wanna keep that sign,
Yeah.
right? So
Okay.
that's kind of what I would want.
So you.
Yeah, we'll back it up. Oh,
Oh,
okay. Yeah, so you have the right first and then you do it.
so what?
So the.
See?
it would be-
This one. It's like that.
Zero.
Can I see?
So what's the factor of the two?
So.
No, you-
Negatives.
Yeah, you're ready.
So it's pretty much just adding in.
It's actually-
No.
Just over you. Where are you getting? Oh, six, I see.
That's their 42.
No, but they are doing it different.
Oh.
Just add. Return back to y squared.
Okay, let's see, you should have y squared. Plus 4y
No.
minus 3y minus 12.
So now it's.
So this is what your first step should look like. So I'm not sure where you're getting the 7 and the 6 from. Somebody had 7 and 6. I know you did.
I had 7 and 6, but I did do the.
Oh, so that's where you got that from.
Yes,
Never
you
mind.
need to
Okay.
I got it. You just need to pick two numbers that add to one.
That was after.
And
Okay, so that's fine, awesome, awesome.
No, so.
All right, so let's see, this guy ends up becoming y squared plus y
Trying to
minus
find
12.
two
and then
numbers that
subtract that
multiply.
30.
Add.
First, yeah, we get 0,
Yeah, something.
y
And then you gotta figure out which is positive.
Right?
But remember the y is constant. So if it's.
So I think most of you made it this far, yes? Anybody who have questions at this point? All right, so what did we use to factor minus 42? So that we got plus 1 as our middle coefficient.
And you wanna get.
What combination works? Come on, I know some of you have the answer. What signs of 6 and 7? -6, +7? 6 and 7, of course, gives us positive, and that's explaining to Kelly here. Usually when you know you're gonna end up with the positive sign in the middle term, that means your larger number has to be positive, smaller has to be negative. If that was a negative y in the middle term, then that means the larger number would keep the negative, smaller would keep the positive. So yeah, perfect. So since this guy is y squared, we know it's going to break down into y and y. So all you gotta do is put -6 in one and +7 in the other. And honestly, in this case, it doesn't matter because you just have y and y as the other two terms. So one of them will be y -6, the other one will be y +7. And as you can see, again, do a FOIL if you wanted to check, but y times y gives us y squared. -6 times -6 times +7 gives us -42. And then the middle term here, again, just a quick check. This guy will give us -6y. This guy here will give us +7y, which will of course end up giving us +1y. So we know that combination works. So what is our solution set for this example here? When you set each one of these equal to 0, what did you get? There you go. This guy will give us +6. This guy will give us -7. So our solution set going to be, when we use curly brackets for this, we have -7. Carmen, did you have any questions on this example?
No, I'm okay.
Alrighty, guys, so this was just another example to show you how factoring as a way of finding the solution for a quadratic equation works. Alrighty, so let's go ahead and figure this out. So this is one way of solving, and as I was telling you, not all your quadratic equations are going to be set up where we can use factoring to solve them. In fact, most of them are not going to be set up for factoring to solve them. So then we come into a second method here, which is, as you can see, the square root property. So the idea is if we can rewrite our quadratic equation in that format where we can get a square term on one side equal to some number on the other side. Which would again kind of involve factoring to be able to get down to this format. Or maybe if rearranging of terms could actually help us achieve that, that'd be great. But the idea is if I can get something squared on the left-hand side equal to some number on the right-hand side, then I can use square root property, because remember, a square root cancels a square. They are opposite functions. It's kind of like how addition cancels subtraction or multiplication cancels division. And we will be talking about inverse functions at the end of chapter 2. So we'll be revisiting this idea, but basically remember, a square is the opposite function, or the actual term would be inverse function of the square root. So they cancel each other out, and that's what we're doing. If we have a square here, we can use a square root to get rid of the square. So the idea here is, once I set this up in this format, let's see if I can kind of keep both of these here. So if I can get that format of x squared equals k, depending on the right-hand side, what kind of k value I have. So if my k value is positive, I will actually end up with 2 real solutions to my quadratic equation. If the number on the right-hand side, that k value is negative, you are actually going to end up with 2 imaginary solutions, because what will happen in this case is you're going to end up with the square root of a negative number. And when we get into square roots of a negative number, we start talking beyond real number set. We're now talking about complex numbers, which is where we begin to talk about imaginary. So we define imaginary number, which of course we use the letter I for that. So we define the number I as square root of -1. And this is what happens if your k value would end up being negative. And then of course, if k is 0, you are only going to get, and they should say real, because you are only going to get 1 real solution. So if you have a positive number or 0, you get real solutions. Of course, with a positive number, you'll get 2, with a 0, just 1. But if your k value is negative, we're talking about imaginary numbers. So let's take a look at an example here, and I think I have one. So you can see they're talking about using the square root property to find either real or imaginary solutions to the equation. And this is kind of what I was talking about. You will see how we have z plus 4, but it's raised to the 2nd power. So that's kind of like our x squared equals k format that we were looking for. So let's take a look at this guy. So we've got z plus 4 quantity squared equals -4. Now your right-hand side is -4. So what does that tell you? What kind of solutions are we looking for? Real or imaginary? Imaginary. So just by this setup, we should be able to see, okay, yes, I am going to get imaginary solutions because my right-hand side has a negative number. All right, so this is where we're going to use the square root property. Plus 4 to the 2nd power. Well, just to show you. Sorry. If you look at the way we're defining, the idea is once you have this format x squared equals k, we set it up as x equals plus or minus square root of k. And if you will remember, last time we had talked about anytime you are taking a square root, it gives you 2 roots, one positive root and one negative root. So that's where this concept is coming from, is even when you're taking a square root on a quadratic equation, you are still going to consider the possibility of I will have 1 positive root and 1 negative root. So you should always end up with 2 roots. So this is where I'm taking a square root on both sides, but on the right-hand side, I'm going to have 1 positive and 1 negative. So on my left-hand side, like I was telling you, the square and the square root are inverse functions of each other, so they cancel each other out. So this is why you're only left with z plus 4 now, because the square and the square root canceled out. We still have the plus and minus. Now the breakdown for that negative 4 with our square root. So we can break this down into -1 times 4. So I'm kind of separating that negative sign from the number. Because as I showed you earlier, the imaginary number I is defined as square root of -1. So we can actually take that negative sign separate, convert it to the number I, and then I can actually take the square root of just 4 then. Because we know square 4 is a perfect square, right? We can take a square root of it nice and evenly. So now I can separate this. I'm going to say, okay, I have square root of -1 times square root of 4. And again, if radicals is something you haven't used in a while, this would be again another thing I'd ask you to review, because again, what I'm showing you is mathematically okay. You can separate the two radicals because now I'm taking -1 separate from 4. The square root of -1 becomes our imaginary number I. And I can take square root of 4, which will give me 2. So this guy will actually end up becoming 2I when you clean it up. Okay. So this guy has now become 2I, and we're ready to get z by itself, which would of course happen by subtracting 4 on both sides. So this guy cancels out here. And you are left with z equals, the notation of how you write complex numbers is -4, the real part in the front, and then the plus or minus 2I, the imaginary part, second. So -4 plus or minus 2I. The format is for complex numbers, we write it as a plus bi. As you will, and of course, the same thing as a minus bi, positive or negative. And then if the numbers are by themselves, like we had on the right side, that is of course going to be the number in the front, I in the back. Kind of like how you would write 2x, the same way you would write 2I, the I at the end. My math lab has a notation where you can type in the plus and minus together like I have here, or you can write them separately. So you can also write this as -4 plus 2I, -4 minus 2I. So remember your two solutions, and in this case, they were both imaginary. So let me see. You will see as soon as we click on the answer box. And I know I'm kind of superimposing on this, but you get this little menu bar and you will see right there on the right hand side near the more is the plus or minus. So this will be -4 plus or minus 2I. Questions on this little guy? How to use the square root property to solve a quadratic equation. All right, let's get an example for you guys to work with. Question number 2. That actually has you solving radical over here and simplifying it. So remember, the first thing you have to do is get it into the format of x squared equals k. And then apply the square root property. Remember, you have two roots, plus or minus. And square root of 8 is 1. So again, plus or minus, you should have both roots. And how do you simplify square root of 8? Because it is not a perfect square. No, move the 8 first before you start doing the square root. You gotta start by moving the 8 to the other side. You have the 8, move it to the right hand side, and then take the square. Very good. Now we're ready to take square root, and then remember you get the positive negative. Okay, very nice. Alrighty. Carmen, share your answer with me. You can just send it to me through chat so I can see what you're coming up with. So we start by moving that 8 to the other side first, guys. Some of you were just doing it on the whole thing, and that's not how this works. Actually. So move the 8 to the other side, and then you can start taking the square root, and remember that's gonna give you 1 positive, 1 negative. On the left-hand side, the square and square root cancel out, and you're left with x equals plus or minus square root of 8, but we need to simplify that square root of 8. Now, like I was telling some of you, 8 itself is not a perfect square number like 4 or 16, 25. But you can still simplify it. So what can we break down 8 into? So that one of those numbers can be a perfect square that we can bring outside. 4, 2 times 4. That's exactly what we need to do. Break down that 8 into 4 times 2. Like I was showing you before with the I calculation, you can write that as square root of 4 times square root of 2, which then again, square root of 4. Nice and clean number 2, but this second guy ends up staying inside the bracket. So 2 times square root of 2. And my MATLAB will ask you to simplify answers. So make sure you are simplifying them.
And that's how it stays.
That's how it says it. No decimal answers, just exact answers. And again, remember, you can write this separately. You can write it as -2 square root of 2 and +2 square root of 2 if you wanted to. Or just use the plus or minus sign like I showed you. So as you can see, once we move the 8 to the other side, of course, we had a positive 8. So you have actually ended up with 2 real solutions in this case. So remember, if the right-hand side number is positive, 2 real solutions, the right-hand side number is negative, 2 imaginary solutions, and you looked at both examples. I'm actually going to skip number 4. That's pretty straightforward because you have a 0. And 0 takes neither a positive or a negative sign. Even when you take your little square root symbol, 0 will not take either of those signs. So you only end up with 1 solution. And you can kind of see what that solution is. All right, let's save this, clear this guy out. Let's move on to our next method of solving a quadratic equation. And you will see we're visiting back our little buddy here, completing the square. So you looked at completing the square with circles. We're doing completing the square with quadratic equations, and we'll be doing completing the square again in chapter 2 with quadratic functions. And we'll talk about functions when we get there. So completing the square also comes into play when factoring doesn't work. So the way our polynomial might be set up is we can't factor. So to make it into something that can be factored, remember that's where the idea of completing the square comes, because now you're turning this expression into a perfect square trinomial. Once you have that perfect square trinomial, we can factor it like we did when we were finding our little circle and radius. Sorry, center and radius for the circle. All right, let's pick our example from MATLAB. I think the next one should be. So couple things, again, as you are working with completing the square. The leading coefficient, which is the term on your x squared term or whatever the square term would be, should be 1. So that's the first thing you're gonna start out with, is trying to find a way to get rid of that 6 from the x squared, make that into a coefficient of 1. And then once you have cleaned that up, then remember to complete the square, we take the middle term, the b value, divide by 2, and then take the square of that number. So we have 6x squared plus 13x. So x squared has to be, and since we are working with the equation, yeah. So make sure your leading coefficient term is 1, and then like they have the 5 on the other side, you do want to move that constant term to the other side. So had the 5 been on the left-hand side of our equation, we would have moved him to the right-hand side, because we only want the x terms on the left and the constant term, because we're going to be coming up with our own constant term. So move the constant term to the right-hand side. Now, the only way you can get rid of, because we're technically not getting rid of the 6, because we don't want to change the value of the equation, we're just rewriting this guy out. You're going to divide each term of your equation by 6. So you cannot just like ignore that 6, we do have to do something with it, and that is division. So the entire equation is getting divided by 6, which will of course help us achieve what we wanted, which is getting our leading term to have a coefficient of 1. So this guy is now just x squared. But now our middle term is 13 over 6x equals 5 over 6x. Can I simplify any of those fractions? Will 6 go into 13 or 6 go into 5? No, we can't simplify them, right? So this is how far we go. So my constant term is on the right-hand side. My x squared term has a coefficient of 1. We're ready to use completing the square. Armin, are you still with me? I can't see your video there. So my middle term divided by 2 into the second power. This is the calculation you need to do for completing the square. Our middle term is 13 over 6. And this is something I had kind of mentioned last time when we were working with circles. If you end up with a fraction like we have in this case, instead of dividing by 2, you can actually multiply by 1/2, and you're still going to get the same result. So in this case, since our b is already a fraction, instead of dividing by 2, just multiply that fraction by 1/2, which is still taking its half, and then you can do the square. So that's what we're going to do here. We're going to take out 13 over 6, multiply by 1/2, and then square the whole. And can you tell me what that value will come out to be? Let's start by multiplying the inside. What is that? 13. 13 over 12, 13 times 1, 6 times 2. And when we square that, what is the square of 13? Very good. And 12? 144, perfect. That's all right. 169 over 144. So this is the term that we need to complete the square on the left-hand side. But remember how I was telling you, if you're going to add something to the left-hand side, we add that to the right-hand side to maintain that balance. So that's what we're going to do next. So let's come back here. We had x squared plus 13 over 6x. And now we're going to add this little guy here. So plus 169 over 144, and that's equal to 5/6 plus 169 over 144. Thank you. Everybody with me so far? If any part of this did not make sense, this is a good time to ask instead of. And I mean, of course, when you work on your own, you can still run into a little confusion, but if you have something that's not making sense, this is a good time to ask. Yes,
So if we just did that 2 and 13/6, why are we then adding square root?
because that's how we want to complete the square, because the way the expression is right now, we cannot factor it out. And to be able to get to that point where we can factor it and then find the solution, we need to convert it into that perfect square. So that's why we're doing. And then you will see when we get to the last method, there's the whole do it all, ignore everything else process, which is using the quadratic formula. But we're kind of showing you different methods, and the main reason for this is, like I was saying, when we get into the quadratic function in the next chapter, there is one type of question where we will have to use completing the square to solve it, because there's no other way to break it down. And this is of course without technology, so you need to be a little more comfortable with completing the square. All right, guys, so make sure you're adding that number to both sides. Now, the right-hand side, we're gonna let the calculator do the hard stuff for us, but let's factor the left-hand side. So this is going to factor into, and this is where you don't have to do the math because we've already done the math. This is going to factor into. So both the factors will be the same. That's how a perfect square trinomial works. We know we have x squared, so the x squared will break down into x times x. Both my terms, the middle term and the constant term, have a positive sign, so this will be positive between the two parentheses. So remember, I again mentioned this when we were working with circles. After you take the 1/2 of your b value, before you square it to get that final answer, this expression right here where we have 13/12, this is what it's going to factor into. So after you've done the b divided by 2 or b multiplied by 1/2, and right before you square it, this number here, oops. Oh, wait. When we had smart boards, they were not as much. This new system that we have is very, very sensitive. Alrighty, so it's that 13/12 that we're interested in. And that is going to be our factor. And check that very quickly. 13 times 13 is 169. 12 times 12 is 144. We know that checks out. We know x times x is going to be x squared. So it's just going to be, when I add the two terms, am I going to get 13/6? Yes, I am. Because when I add these, let's do this as patchwork. When I add 13/12 with 13/12, I have the same denominator. So d stays the same. 13 plus 13 is 26. Reduce that down, what do we get? What's common between 26 and 12? Yeah, nothing higher than 2, right? Nothing else will go in there. So 13 divided into 20, sorry, 2 divided into 26 gives us 13. Of course, 2 divided into 12 gives us 6, and you can see you end up with the middle term. So we know this guy is going to work. When we rewrite it, you actually don't want to write it as two separate parentheses. You actually want to write it as x plus 13/12, and then you want to put that square, because we are actually going to go back and use the square root property to simplify this. What does our right-hand side addition come out to? I'm actually gonna show you. Both names because I do have to do business. I'm gonna use their scientific calculator because obviously we don't need the graphic. Again, I know it's kind of like superimposed with my writing, but we are trying to add 6 with 16, 44. and then see that, and I really do apologize. So of course, I've got my 5, 6 plus 169 over 144, but you will see by default, it gives us a decimal answer, but it's got that little fraction symbol next to it. So if you just click on that, it's gonna give me a fraction. So it saves your trouble of, finding the common denominator and all of that. Not that you don't need to know that, but at this stage, remember, we're more testing you for concepts than can you do the math. I'm imagining you can do the math. So this is the answer we're looking for, 289 over 140. 289. All right. Okay, let's use the square root property going forward. So using the square root property, and I'm just going to change my color here because there's too much writing. Take the square root on both sides. Remember, the right hand side will be positive. Yeah. Which also means my square root and square here will cancel each other out, which is what we wanted. Leaving us behind with just x plus 13 over 12. And then plus or minus, can you tell me what is the square root of 289? And I do believe it is, what is it? 17. Very good, thank you. And of course, 144 we know came from 1112. Now, what do you do to get x by itself? Subtract 13 with. And of course, when you're subtracting 13 over 12, you need to do both with once the positive and the negative. So that would be positive 17 over 12 minus 13 over 12, and then you will be doing negative 17 over 12 minus 13. So we get x by itself, and then what are our two solutions? Seventeen minus 13 should be pretty. It should be good. Seventeen minus 13. Sorry? So you're subtracting, right? 412, and what will that reduce up to? 1/3. So that will be one solution. Negative 17 minus 13. That will be negative 30, which will again reduce 1 to. Negative 5 over 2. The 6 would be common, right? Oh. So. All right, so our two solutions are positive 1/3 and negative 5 over 2. basically. Okay, let's do this one. So this is completing the square. Again, it is essentially every single step that we did with the circle example last time. But the only difference is once you have factored your expression and cleaned up your right-hand side, you do need to go back to the square root property to actually find the solution. So that would be the new thing you'd have to try. Um, I can do that. Okay. Let's try, we'll keep it simple for you guys. Let's try number 6 for completing this square as well. M square minus 12m plus 33. So of course, our leading coefficient is already 1 for the m square. So start by moving the 33 to the other side first. Then you are doing your b divided by 2 the whole quantity squared. And once you have that calculated, let me know what you come up with. B divided by 2 the whole quantity squared. And just a reminder, since we square, you can leave the negative out. You don't have to take the negative with the number, because technically b would be the middle term, right? Negative 12. But because we know we're gonna square our answer, you'll see I never bothered with taking the negatives. So what is that constant term going to be that's going to help us complete this with 36? Yes, no, maybe, I don't know. I have no idea what I'm doing here next. Did anybody not get 36? Okay, so your middle term is 12, which is coming from that m term, 12 divided by 2, which is 6, and then of course you're squaring the whole thing, which is where 36 is. So you're going to take that 36 like we did in the previous example. Factor the left-hand side, add the right-hand side. Okay, so once you've added 36 to both sides of your equation, you are factoring the left-hand side, which is now a perfect square trinomial, and then just add the two numbers. And as I was telling you before, right before you square the number to get your 36, that number in the parentheses is what you're using for factoring. So you don't have to go back and redo the math, that number is already there. What does your factored side on the left-hand side look like? M square minus 12m plus 36. No, just the left-hand side when you factor. When you take m squared minus 12m plus 36, and then you factor it for the g. Yeah, very good. So you are factoring this guy. Of course, this is m and m. You have a negative sign in the middle, so both of these guys will be negative. And then using that 6 from, when we did completing the square, you're just gonna put these guys as 6 and 6. Or you don't again have to write it twice. You can just say it's gonna be m minus 6 in the second half. So you can skip that step. Okay, what does the right-hand side give us when we combine negative 33 with 36? Alrighty, so at this stage, we are ready to use the square root property now. So you have m minus 6, the whole quantity squared on the left-hand side, and that is equal to positive 3. So since we have positive 3 on the right-hand side, you're going to get 2 real solutions. Okay? Square root property. So we'll go ahead and take a square root on both sides, and remember you get one positive, one negative root. So that would be m minus 6 equals plus or minus square root of 2. Right, perfect, very nice comment. Then all you're doing is adding 6, taking it to the other side. Can I simplify square root of 6, square root of 3? Does that break down? No, it will just give us a decimal answer, right? We can't simplify it like we had done square root of 8. So this guy will end up giving us positive 6 plus or minus square root of 3. And this is again the notation of how you write if you have a radical left behind. Because we're not multiplying 6 into square root of 3, so I cannot just write it 6 times square root of 3 like we had done 2 square root of 2 when we broke down the 8. That doesn't happen here because your square root of 3 has that plus or minus sign in front of it. So the 6 is basically getting added on to that expression. So that's why you have to have 6 and then the plus or minus and then the square root of 3. And again, if you wanted to write it separately, you can write it as 6 plus square root of 3 and 6 minus square root of 3, or using the plus or minus. Either one.
Did you say that 6 has to go forward?
Normally, my math lab would probably be okay if you did the plus or minus square root of 3 and then put the plus 6 at the end. But again, as a mathematician, I have to let you know what's the proper form. You do whatever works best for you. As long as you're not putting 6 times square root of 3, we're fine. So you can put the square root of 3 in the front, the 6 in the back. Just make sure you have the sign. So that would look like plus or minus square root of 3 in the front, and then the plus 6 in the back, if you were switching this. Just remember, these are commutative numbers, so you can move those because addition and subtraction are both associated and commutative. All right. So we've looked at 3 different methods so far. You have looked at factoring, square root property, and completing the square, which completing the square kind of goes back into square root property to get the final answer. They're just giving you a list of steps on how to go about doing completing the square, so this may just be a nice review. But this is it, guys. This is any quadratic equation, doesn't matter if you can factor it, doesn't matter if it can be done with square root property, completing the square, all quadratic equations can be solved by using the quadratic formula. Obviously on the exam, because we are wanting you to know how each of the methods work, you need to follow those instructions. But once we get beyond this, and anytime you see a quadratic equation, if this seems to be, this will get me to the answer, you can use it. All right, so the way this guy works, you have to have your equation in the standard form if you are going to use quadratic formula, because you have to have ax squared plus bx plus c on one side, and you have to have 0 on the other side for this to work. Just like we did with factoring. So once you have written out, then look for your a, b, and c values. And in this case, you do need to take the sign with the number. So if you have a negative in front of a or b or c, make sure it makes it into the formula also. And then this here is your quadratic formula. Negative b, you will see right before the square root sign, we have that plus or minus, because just like we did with square root property, we know every time we take a square root, you get 2 roots. So that's where that plus or minus comes from. Then you have b squared minus 4ac, and the whole thing is divided by 2a. The b squared minus 4ac, that little part which is inside the square root symbol, is what we call as the discriminant, because it helps you determine what kind of solutions you will get. So if this number on the inside of the square root, the b squared minus 4ac, if that number comes out to be positive, you will have 2 real roots. If that number comes out to be negative, you will have 2 imaginary roots or solutions, roots or solutions. And if that number comes out to be 0, you have 1 real solution. I think we talk about discriminants. Yeah, we talk about discriminants later on, but I kind of like to talk about it while we're working through this. So basically, like I said, whatever is inside that square root, if it comes out to be positive, you have 2 real solutions. If the discriminant comes out to be negative, we have 2 imaginary solutions. And if the discriminant is 0, you have 1 real solution. And you can kind of see some of that in the table. All right, let's take a look at an example with using the quadratic. Okay, so the first step would be putting this in the a squared plus ax squared plus bx plus c equals 0 format. So obviously you can see we need to take that 2 and move it over to the left hand side. So this will end up giving us 5x squared minus 2x. 2x, and then we added the 2. And then 0. Looking at this, can you tell me what are A, B, and C values? Once you have put this in the standard. What is our A, B, and C value? Jacob?
A is 5, B is 2, -2, and C is 2.
Very good. So yeah, take the sign with the number, because here it makes a difference. With the completing the square was a different issue because we were going to square that number, but here, if you leave the sign out, of course, you can imagine your math will not work out quite the same. So negative 2 was just for the B value, everything else was positive. All right. So x equals negative b plus or minus square root of b squared minus four AC, and then the whole thing divided by two A. Now remember, the b squared minus four AC will tell us if we're going to get real, imaginary, or two or one solutions. Okay, so when you're plugging in, we have negative from the formula, and then our b is also a negative number, so you should have two negative signs. Right? Negative from the formula, and then negative from the number itself. So negative times -2. Plus or minus square root, you again have b squared. So since my b is negative, I'm going to put this in parentheses. So this is -2 squared. Now this is what I have seen happens. If you guys write it as -2 squared without the parentheses, and if you're using calculator to solve, your calculator is not going to take that negative into the square calculation. It's going to do 2 times 2, give you 4, and leave the negative behind. So be careful, because you are squaring -2, which means negative times negative will end up becoming positive. And so parentheses helps. That's where we know the sign is also being squared. All right, so that's b squared minus 4 times A. A is 5. C is +2. So that's 4AC inside, and then on the bottom, we have 2 times A, which will be 2 times 5. And then you're just cleaning that up. So let's see, we will have negative times -2, well, of course, 2 negatives becomes positive, so +2. Plus or minus, we have -2 squared, which will become +4. Minus, we are multiplying 4 times 5 times 2, but there's only one negative sign, right? So that negative sign, the minus stays. 4 times 5 is 20, 20 times 2 is 40. We are going to end up with what? A positive negative number inside that radical. When you do 4 minus 4. Negative, so this actually tells us we're gonna end up with 2 imaginary solutions here, guys. Bottom, 5 times 2 is gonna be 10. So we have +2 plus or minus. When we do 4 minus 40, what do we get? -36 over 10. So since we have -36, we are going to have 2 imaginary solutions here. Now it's just a matter of cleaning this up. 2 plus or minus. Is 36 itself a perfect square number? Yes. What can we do with that negative inside the square root? How did we break down our little -4 with the square root in that one example? Yeah, exactly. So I'm gonna try and do this a little bit on the side, so I can save some space here. So we have square root of -36. So same thing like I showed you, separate that negative sign from the number. And you can write it out as 2 different radicals with the multiplication. So what will our square root of -1 end up becoming? Very nice, imaginary number I. And what is the square root of 36? 6. So as you can see, this guy will end up becoming 6i. So that's our little scratch root on the side. So you get 2 plus or minus. Now negative, square root of -36 has become 6i. So I'm going to write this guy as 6i. And this is divided by 10. Now, when you simplify this, it does actually help to separate that fraction. So 2 divided by 10 plus or minus 6i divided by 10. So let's reduce those fractions. What will be 2 divided by 10? Very nice, 1/5. Plus or minus, and then we're gonna leave that I on the side, and then you're just simplifying 6/10. Good, very nice, 3/5. So again, if you wanted to, you can write this as 1/5 plus 3/5 I and comma 1/5 minus. These are what I call as non-happy numbers. So if your equation is going to have a solution which is going to look something like this, the quadratic formula definitely works out in the best way. Technically, this example can also be solved by using completing the square. I think that's it. The other two will not work. So you can use completing the square, or as we saw, quadratic. All right, let's put this guy in. So we had 1/5. Other one was 3/5. Between my two actions and. Questions on this example here? Using the quadratic formula. You will see the examples like these where you especially have a leading coefficient on your square term, which is not, one. The quadratic formula works out pretty well in that, because if we were going to use completing the square, then remember you would have to divide by that leading term, right? So we would have to divide the first example by 16, the entire equation, or the second one by 9 if you were going to use completing the square. So sometimes maybe when you have that leading coefficient, which is not 1, quadratic formula works out pretty well. So as I was telling you with the discriminant, they have some examples here where they're just asking you to find the discriminant. So they're not asking you to solve the entire equation. They're just saying determine, are you going to have two real solutions or two imaginary solutions, or just one single real solution based on, did my discriminant value come out to be a positive number, negative number, or 0? Let me see if I had picked an example for that. Because I did. Okay. So here we're just looking at the value of the discriminant. So remember, that is the part where you're just doing b squared minus 4ac. We're not doing the entire equation. So plug in your numbers for a, b, and c and tell me what is your value of the discriminant come out. So first start by writing down what your a, b, and c values are, and then put it into the b squared minus 4ac format. Make sure you're taking the sign with the number when you're writing down your A, B, and C. Katie, can you tell us what the A, B, and C values are? Just two.
Oh, B is 6.
Positive, negative. Yeah, take the sign with the number and C. So when we plug this in, you will see again, you have that B square, which means you again need to do -6 in parentheses and then square that. Minus 4 times A will be 2. C will be 11. What is our value? Eden, do you have this value of the discriminant? Did you multiply this out?
No, I got it to there, I did.
Okay, so tell me what will -6 square come out to? You can use a calculator, you don't have to do anything. And Bill, can you tell me what 4 times 2 times 11 comes out? Oh, 4 times 2 is not fair. It's not two. 8. And 8 times 11. Alrighty, so when we subtract these two numbers, guys, what do we get? 36 minus 11. Yes, it will be -52. So if we're getting a negative number, what type of solutions are we talking about? Imaginary, yes. We can't believe this one, yes. Nice. So this one you will notice is they are asking us. All right, perfect, very nice, Carmen. They're giving you the options of 1 real, 0 real, 2 real cannot be determined, which again, that cannot be determined is just to throw you off. So don't choose that option, because more often than not, you're gonna have one of these. So you will see they didn't really give us the option of imaginary, right? But this is telling us, since it's an imaginary solution, it's not real. So technically, we are getting 2 imaginary. We are getting 2 imaginary solutions, which is the same thing as not real. Yeah, it's kind of convoluted, but I don't know why they just didn't say 2 imaginary instead of 0 real, but since we don't have any real solutions, they're both imaginary, you are choosing the option of 0 real. And so basically, if this had turned out to be a positive 52, you would have said 2 real solutions. If this would have turned out to be 0, if the value of the discriminant came out to be 0, then you would have said 1 real solution. So that's kind of how this guy works. And I think this is actually the end of 1.5. All right, guys, so we're gonna pick up from 1.6 and 1.7 next time. So obviously, we're not taking our test on Tuesday. We're gonna move it to a week from today, Thursday. Yes, I'll go ahead and make the changes.